This tutorial is going to talk about section 3.5, which is mainly about the Polygon AngleSum Theorem. In order to actually get to this theorem, though, we have to have a few things understood. And the first thing that we need to understand is what exactly a polygon is. So, there's a few parts of this definition, then we're going to take a look at a couple of examples. The first thing that a polygon is a closed plane figure. That means that it is two-dimensional on one plane. The next thing that we need to know is that at least three sides are segments. So we need at least three sides in order for this guy to be a polygon. The next thing is that the sides that you have intersect only at their endpoints. Nowhere else. The segments are not going to intersect each other, only at their endpoints. And the very last thing is that no adjacent sides are collinear. That means that no two sides can be on top of each other, which should be pretty self-explanatory, because we haven't ever seen a polygon like that. So let's take a look at a couple examples and see if you can determine if it's a polygon or not. Alright, so let's take a look at this first figure. First of all, it is a closed figure, so it fits the first condition. It also has at least three sides that are segments. In this case, it has five. The sides do only intersect at their endpoints, and no adjacent side are on top of each other. They're not collinear. So this first picture is a polygon. The second picture is not a polygon because it doesn't even fit the first description. It has to be a closed plane figure. So this is not a polygon because it is not closed. This would have to be connected in order for it to even fit a polygon definition. The third one here, it fits the first two criteria, but it fails the third because it says sides intersect only at their endpoints. This is a problem because neither of these places are endpoints, so this is not a polygon either. Alright, let's move on. We can have two different kinds of polygons. We can have either convex or concave polygons, and the difference is in the diagonals. So take a look at convex. A diagonal connects one endpoint to another. So if I connect these two, and then connect these two, and then these, you'll notice that all the diagonals are within this polygon. So all of the diagonals are inside the figure. Whereas a concave, if I were to connect all the diagonals here, I've got this one, and this one, and this one, and then this one. You'll notice that some of the diagonals are outside the polygon. So this one says at least one diagonal is outside the figure. So that's how you can tell whether you have a convex or concave polygon. And there are some common polygons that you need to know the names of. So let's take a look at those. Okay, so let's take a look at some polygons with these number of sides and their names. You'll notice that some are left out, and that's because they're just not common. So any polygon that has three sides is called a triangle. 4 sides is called a quadrilateral. 5 sides is called a pentagon. 6 sides is called a hexagon. Notice that we skipped 7. 8 sides is an octagon. 9 is a nonagon. 10 is a decagon. We skip 11. And then we say 12, which is a dodecagon. So the very last one that you see here is an N, and that stands for any number of sided polygon that's not one of these common ones. We just say it's an N-gon. So for example, that 7 that was missing, we would just call a 7-gon. Or the 11 that was missing, an 11-gon. So I know it sounds kind of funky, but that is how we name them. So if it's not one of these common ones, You tell me the number of sides that it has and then gone after it. Okay, so now that we have our knowledge of polygons, we can finally approach the Polygon AngleSum Theorem. And this is what it says. Alright, and here's what it says. The sum of the measures of the angles of an n-gon is n minus 2 times 180. And this simply comes from the number of triangles that fit within a polygon. That's why there's that 180, because that's the sum of the measures. If you really want to know specifically where that comes from, come and see me during tutorial time or cohort time, and I'd love to show you. But let's take a look at an example and exactly how I'm supposed to use this. So here's our example. It says, find the sum of the measures of the angles of a 15-gon. So in this case, when we use n minus 2 times 180, so I'm just going to rewrite that. My n stands for the number of sides that this particular polygon has. And in this case, it is 15. So that's what I'm going to substitute in for n. So I'm going to say 15 minus 2 times 180. And that's going to give me 13 times 180, which is equal to 2,340 degrees. So in any polygon that has 15 sides, you're looking at an entire sum of measures of 2,340 degrees. And that's a lot. And we have one more theorem that goes along with this to look at, and then we're all done. So let's look at the next one. So the next theorem is called the Polygon exterior AngleSum Theorem. And this is built off of me extending all of the sides of my polygon so that I have exterior angles. So I'm going to go ahead and do this. I'm going to extend this one here, extend this one here, and here, and here, and here. So I have 1, 2, 3, 4, 5 exterior angles. And there is a direct relationship between this. And it's for any polygon in general. And that is that all of the sums of the exterior angles adds up to 360 degrees. Like so. So measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5, and so on and so forth should add up and equal 360 degrees. So that you can see how you might have to use this in an equation, and it can get a little bit messy. But that is, this is true for every single kind of polygon. And the very last thing I want to talk to you about is something called a regular polygon. Regular polygons are really useful because we see them a lot, and they're just considered to be very nice to look at. So a regular polygon has two characteristics. One is that it is equilateral and equiangular. So, like an equilateral triangle has all three sides congruent, that would be a regular polygon. And if you have all your sides congruent, that implies equiangular. So they're really the same thing hand in hand, but we just call them different things just to be more specific. So that concludes this tutorial.